Hello, Algebra 1 people. It's me again, your favorite summertime guy. If you're looking for lesson 61, simplifying radical expressions, you found the right place. Let me go over a few things you're going to need today before we get started. You are going to need a pencil. You are going to need something to write on. Anything you write in here, you're allowed to use on your test. It's to your advantage to do more with this than not to. You're also going to need the Algebra 1 reference sheet here that I emailed to you. You're going to need some homework paper. You download that, print it off because you're going to need to scan it, photocopy it. You're going to need to email it to me or put it in the mail so I can grade your work. You also need paperclip, ham sandwich. Where's my ham sandwich? Oh, you gotta be kidding me. Okay, you don't need a ham sandwich. Yeah, that's about it that you need for right now. So let's get going with a few things. If you look back in your book at lesson 46, you'll find some skills in there that will be helpful for today. This is kind of a next step from that lesson. Again, it's lesson 46. If you look in your book, there's some info in there that'll help you. And one of the things that I want to make sure that you have written down in your stuff is about square numbers, okay? Probably 1 through 12 you memorized as a kid. You should definitely have those ones down. 1 squared is 1, 2 squared is 2, 3 squared is, that's 4, 3 squared is 9, 16, 25, 36, 49, 64, 81, 100. And then these two you probably know. But these ones you need to write down because if you recognize them, it's awfully handy for you for doing your math faster, especially today. So 13 squared is 169, 14 squared is 196, 15 squared is 225, 16 squared is 256, 17 squared is 289, 324, 363, 400. And you probably should check my work because I was doing it all in my head. Write it down. I'll walk out of the way, hit pause, write it down, and then unpause, and we'll keep going. Okay, next. Skills you're going to want to know. A little bit of prime factorization is going to come in handy today. We'll talk about that here in just a couple minutes. But the lesson is about radicals. Actually, it says radical expressions. So let me talk to you about that really quickly so that we're all talking the same language here. You want to see a radical expression? It's pretty radical, isn't it? Yeah. But that's not the mathematical type of radical expression that we're talking about. No, don't be silly. Radical means one of these things, which we would typically say is a square root sign, but square root technically is like there's a 2 there, and this means the cubed root, and this means the 4th root. It's just kind of, it's called the index, and it tells you how many times something has to be underneath that root sign multiplied by another thing to be taken out, for that square to be unsquared, or that something that's in there 3 times to be taken out from underneath that. We're familiar with square roots, okay? So knowing your squares and then knowing what it came from is going to be pretty helpful because those are inverse operations and they undo each other. Squaring and square rooting undo each other. We're going to stick with some of the basics here today. We're not going to get too complicated, but radical, it's going to have one of those signs on it, one of those little check mark signs. And then an expression just means it doesn't have an equal sign, okay? There's no equations here. It's just an expression like a math problem to solve, but not with an equal sign. So with that, we got one kind of seemingly obvious rule here for these. If you have 2 things under a square root sign, under a radical sign, and you're going to multiply those things by each other, you can just slop them together under one radical sign. And then the flip of that is that if you have some number that can be broken down into factors, into something times something else, you can break that down into the square root or the radical here of this and the radical of that. I know those are like the same thing, just written in opposite orders, but it's really good for you to get used to seeing things in both directions. Just because we read from left to right doesn't mean we always have to do math from left to right, though I do think that's awfully helpful sometimes. We can split this up, or we can put it back together, whatever's going to help us, you see up here, simplify, okay? Simplify your life. It's a good idea. So we're going to do things with this. It's going to be handy in simplifying sometimes and sometimes in combining things. So it's a skill that we're going to pick up again as we go along. Now let's talk briefly about prime factorization. That'll come in handy here. We're going to take a number, a bigger number, a number that's called a composite number. A composite number is a number that can be put together by multiplying prime numbers together. Prime numbers are those seeds of numbers. There's where all the numbers start. And where did I put my prime number list? It was right there. Just placed it. But that kind of thing comes in handy for breaking things down in smaller pieces and seeing what there is, and then maybe putting them together back in a new way. Like when you get a Lego set and then you lose the instructions and you want to make something up. You still have all the pieces and you want to put it all together, but it doesn't always end up looking exactly the same as it did before. So we're going to start with something like the square root of 225, which was on our squared list, but let's assume that we don't know that that's 15 squared. We can think of it in terms of what is it divisible by? 5, 6, 7, 8, 9. It is divisible by 3, but I can't picture in my head what 3 times something equals 225 is. But I could think of it like this. I could think of it in terms of money. 225 pennies is $2.25. If I treat 25s like quarters, I'd have 1, 2, 3, 4, 5, 6, 7, 8, 9 quarters. Okay, so 225 is 9 times 25, and that's a square number, and that's a perfect square number as well. So I could rewrite this as square root of 9 times the square root of 25. And now it gets easier because the square root of 9 is 3, the square root of 25 is 5. 3 times 5 equals 15, the square root of 225. Don't use your calculator for this kind of stuff. Use your brain, okay? This is summer school, man. You gotta no cheating. Here's another one. Not a perfect square. It's not on our list, but let's start doing a little bit of prime factorization. 72 is divisible by 2, and those should be fairly easy for you to figure out in your head. That's 2 times 36. So we might want to stop right there because 36 is a perfect square. It's 6 times 6. So 72, square root of 72 breaks down into the square root of 2 and the square root of 36, which is 6. And so the answer to the square root of 72 is 6 times the square root of 2. There's nothing else you can do there because I can't take that 2 out from underneath the radical sign. That's as far as I can go, and that is an exact answer. That's a very good answer right there. And typically they put any number that you can pull out from underneath that square root sign in front, and whatever's left underneath the square root sign goes second. Let's look at another one. And I know I'm doing these fast, but you can always go back and watch it over again. We'll take the square root of 180. So you can do the whole prime factorization with thinking this is 2 times 90, and that's 2 times 45, and this is 3 times 15, and that's 3 times 5, and then find pairs and say, well, this is the square root of 2 squared, which is 4, and the square root of 3 squared, which is 9, and the square root of 5, so you get 2 times 3 times the square root of 5, which is 6 root 5. You can do it that way, but I kind of want to look for maybe the first thing that I think of when I see 180 is 18 times 10. That's kind of just the definition of the place values there. And 18 is 2 and 9, and 10 is 2 and 5. So there's my pair of 2's, and there's my other perfect square, 9, sitting right there. Anyway, all these would still be underneath that. 2 times 2 is 4. The square root of 2 times 2 is 2. And the square root of 9 is 3. And there we are, we're at the same place that we were before. Simplification, and it's quick because I'm taking bigger chunks, and then breaking down those bigger chunks into smaller chunks. But you could do the big, long, I don't know, factorization tree or factor ladder or whatever you've learned before to help you break those down. Some of the other ones would be like powers of 10. Powers of 10 are easy because basically, if you want to write this as a number to the power of, you can just count zeros, okay? All powers of 10, all these kinds of things are going to basically be 10 to the number of zeros, 1, 2, 3, 4. And this just means 10 squared and another 10 squared, right? 10 to the 4, we just add those exponents. Now we're splitting it apart. Now we can even rewrite that like this. And I know what that is. That's 100. Square root of 100 is 10. And the square root of another of 100 is another 10. 10 times 10 is 100. Therefore, 10,000, the square root of 10,000 is 100. If there's an even number of zeros, that's really nice. And we can get these perfect squares. If there's an extra zero in here, well, that's just our previous answer times the square root of 10 again. That is, it's that. We know what this is now. That's 100. And we don't know what that is, and we can't break it down any further. 100 times the square root of 10, best that we can do. Let's throw some letters in there. Let's put numbers and letters together and see how this would work. So I'll take here the 81, x to the 4th, and y cubed. And one thing to note about this is that every time you get any letter, you can pull out a squared business underneath that thing. You can pull that letter out all by itself. Okay? So make a note of that, write that down in your notes, and use that as often as you can. So that means this one turns into square root of 81, which is on your list of squares. That's 9. We would have x to the 4th, which is x squared, and x squared again. And then y cubed is y squared, and we're left with 1y under the radical sign. All these four here, you can pull those values out and have them sitting out in front. This one, you have nothing, no pair, so it has to stay there all by itself. So this is 9. That is x, like the rule says here. There's another one of those. Here's one version with y in it, and then I'm left with that. So putting it all together, 9, 2 x's, a y, and square root of y. Easy peasy Japanesey. Maybe it's easy. That's why we're going to practice this stuff. Here's another one. Last example. 162 r to the 4th and s to the 8th. Anytime we can get a letter squared underneath the square root sign, we can pull it out. Here we got big number. This is just 2 times 81, and there's our perfect square. So this is square root of 81 times square root of 2. And then here we got an r squared. We can have another r squared. And then we're going to have a series of s squareds. So that can be solved. That cannot. We've got an r and another r and 4 s's. And if we smush it all together, we get 9r squared s to the 4th square root of 2. And that's the best we can do. If that doesn't make too much sense and I went super fast, just back up a minute, watch it again, hit pause, try to see if you can figure out how I went from step to step. Last thing I want to say is that your lesson 61, don't do lesson 62 until you have done lab 6 so that you know how to push the buttons on your calculator. I'll be seeing you soon.